Welcome everyone. It's 45. I have a lot of content to cover, so I need to start immediately. So welcome. It's very nice to see some friendly faces. I had time to talk yesterday. It was a pleasure. Today I'm going to talk about Agentic AI. Now, my colleague Duncan, he had a very nice and interesting presentation yesterday. He was talking more about the concepts. Now, our perspective here is more how to industrialize that Agentic AI services, so when you want to move them to production. And what are the requirements, so what is that blueprint required for these agentic services to be able to be an industrial service. But my focus will be mainly today on showing a few of these practical use cases, showing some demos, showing some code, how to do that. And again, I will do just a high-level overview of what Duncan did yesterday, just for those that didn't have time to attend. So, and of course, my name is Alan, and I'm a principal solution architect at Akka. Okay, so now AI is here to stay, right? And it's transforming our lives. So, I mean, mainly today, we are using AI assistants as kind of user-facing applications to help us kind of they understand natural languages and they help us, in a conversational way, how to solve certain tasks. Now, with, of course, a need to use that advantage of AI, or in this case, LLMs, there's also the need to optimize this process. So that's where the AI agents come in, and the way agentic comes in. So where we have now systems that can autonomously are communicating now with different agents, with LLMs, of course, with different systems, but also they're using kind of humans in a loop. So I'm just setting some information for us to have a common ground. Now, LLMs, so they have a static general knowledge. So they know what they know. In the moment where they are kind of trained, this is what they know. That's all they know, right? So they cannot cannot perform any side effects. They are stateless in nature. So if you want to have any session, conversation, history, it's not something that LLM does for you. They're also non-deterministic. So you need to also take that in mind. They are low in throughput, at least for now, and they're also very costly, also now. And the interaction is very conversational, so it's not transactional. So these are some of the things we need to take in mind when you're kind of designing these systems. Now, kind of to customize, optimize, and optimize all this process, we would use software engineering principles and solutions. So this is a task for a software engineer to solve. Now, this is where Agentic AI Services come in. Now, they provide kind of common patterns, how to augment that content, so to extend the knowledge that LLM needs to know and didn't know because it was built maybe without that information. Also to allow maybe calling different tools to allow them to do side effects, but kind of more complemented to do a side effects. It also adds that statefulness to it. So for example, the conversation, the session, is something that is responsibility of an agentic system. And also you need to embrace failure, meaning because there is a non-determinism in that loop. There's also that conversational interaction, so you need to embrace that there will be failure. So when you design this from an engineering point of view, you need to understand that there will be failures for sure, and how can you model them inside of in your domain. These are some common patterns. I kind of pulled out 3 from Anthropic. One is this RAG, so retrieval augmented generation, where you kind of complement LLM with the ability to query different information, to retrieve additional information that you want to enrich to be able to work with, then kind of allow them to, or not allow, but complement to call different external tools. And then, of course, the memory, use of memory to make it stateful, so it remembers our conversation that we had. Now, workflow and agents are patterns how to interact and how to use LLMs there. Now, the workflow are more kind of static, where this is a pattern where LLM doesn't orchestrate that business process. It's something that is predefined. We are using, of course, LLM here for some reasoning, but agents are fully dynamic. It's where the LLMs are doing that orchestration. So they are defining, based on their reasoning, what and how things need to be performed. Now, yesterday, Duncan was talking about, from us as Akka, what should be a blueprint for these agentic services to make them production ready. Now, this is kind of a layer of connectivity adapters that's mainly the industry is investing in. So these are all these AI SDKs, LLMs, vector databases, clients for vector databases, and so on. So it's kind of very dynamic, how this is changing in different programming languages and so on. Now, also, there is a need to have tool integration. So we need to, in these patterns where the tools need to be called, there are also kind of emerging protocols for that, like, for example, MCP, Modular Context Protocol. But of course, you need to have a way to integrate all of this with your own system inside, with your application landscape. And there will be different types of integrations, asynchronous, synchronous, streaming, non-streaming, batch, different kind of protocols. And what is important here is that we know that this is very slow. So we need to be able to accommodate all the traffic that is coming in with the pace that LLMs can cope with. So we need to have a way to back pressure this communication, and then to allow level of scalability. Now the focus, how to make it industrial, we need to focus on security, we need to focus on scalability, we need to focus on resilience, observability. I mean, these are standard things in software engineering that you need to do, right? Now, as I said, focus in the currently is mainly here. It's kind of going inside out. And now many of them are POCing in this direction, but then when you want to make it a more industrial production-grade system, you need to consider these things. Now, important parts of making it secure, it's kind of this agent lifecycle. So how can you run, scale these agents in the infrastructure that you have? You need to do it automatically, you need to do it scalably in a way. So you need to implement different kind of event-driven patterns, because this is very event-driven, how it works, because it's conversational. Yeah? Now also, if you, for example, need to have human in a loop, that will be kind of more event-driven way how to do it. So you need to be able to enable this in the platform, make it also in industrial well to scale based on your requirements. Yeah? Now, the second thing is orchestration. So orchestration as a part, you need to be able to implement these patterns. These patterns are very stateful in nature. So there's kind of this step way how you do things. So you contact vector databases, you communicate with LLMs, you communicate with different tools. All this is very stateful, and it's very event-driven how it works. Now, it's very costly from a resilience point of view to, in case of some failure, to restart everything. And this is kind of a common pattern in software engineering. You just restart and just everything works fine. Now, this will be costly with LLM communication. You cannot just retry this millions of times, right? So this means that from a resilience point of view, you need to store these steps. Each of the steps it does, you need to store it. So you need to have some way of a workflow way how to handle that durable execution. And then not just that, how you can scale it. Because all of these workflows or these executions will be per session, per instance that we are solving, whatever. And it will be millions maybe of those that we need to handle. And also we need to consider this communication, also how to cope with the slowness of this communication here. And the third thing is this memory database. So because for making things store conversation to make this stateful, and this is very partitioned data that's there. That's partitioned per session that you do, per instance that you solve, or something like that. How you model that workflow, this is kind of partitioned based on that. So there'll be a lot of those that you need to maybe scale out, maybe require also some kind of a redundancy there, maybe in a multi-region setup or something like that. So this is something that's important for you to be able to make it a production-grade system. Now, we at Akka, we are not AI experts, okay? So this is not our domain. This is what we do already for more than 10 years. So our focus, and I mean architectural patterns that Akka promotes, is that durable execution, how to implement distributed systems in high scale. That's what our main focus is and expertise is. Now what we see that having these principles of patterns, having a proven platform to do, and then run these kind of very dynamic integrations on top, allow you then to kind of control them. Make these things much controllable, especially embrace failure in that perspective, and then model that as part of your business logic. Now, as I said, Akka is a platform for implementing durable execution distributed systems. Now, we kind of offer two things around for developers in this SDK. So there are these 6 high-level components that you can use. You can combine them to build kind of very rich and complex architectural patterns, where you can then implement, for example, entities or these in-memory databases that you can use to store conversations. They are by default partitioned, scalable. Then workflows, you can implement these durable executions, these workflow steps that you need. They also provide that point-in-time recovery. So it's stored for resilience purposes every step that you do, and then automatically is recovered in case of failure. And also each of these instances of that workflow is dedicated for specific session or specific instance, whatever you're modeling in your system. Then streaming, of course, because you need to have different integrations with or toolings or with external systems. You need to maybe pipe in information to different producers, consumers of that data. And also, they are by default scaling in and scaling out automatically. Timers, if you need to implement some timeouts, and there are durable executions that you need to do, like a cron, for example. Then endpoints to design HTTP endpoints, gRPC for streaming data in also. And then views, they are more kind of building different read representations, so how you can query this memory, for example, representations in different fashion by different attributes, for example. And then there are different operational environments. Now, first focus is on offline development, so allows you a sandbox environment locally where you can build all these things. Now, experiment, kind of bring these tools inside, test them locally, so it gives you a way how to debug, develop everything. And there is no requirements for infra locally. And I mean, the focus is on that low friction in development. And then, depending on your internal production setup, or you can do kind of self-managed nodes where you can deploy this in a multi-node environment, or there is a kind of fully automated environment that we provide, in a sense, kind of like a serverless environments, or it's a kind of bring your own cloud where we provide your account, we provision full infrastructure inside, or it's a self-hosted where we kind of give infrastructure as a code and you provision things inside. So there are kind of different flavors that you can use. Okay, let's start with the first use case. Now, this is one of the we did with one of our customers. I renamed it just to be able to use it publicly. Now it's kind of instance resolution system. So we have our current system. So let's say the thing we did, there was an invoicing system and then was a payment system. So when the payment system did the payment, for some reason there was not a billing address. And then there was a reconciliation process happened that there was an incident raised with saying, okay, I have a payment that is missing some information in. And then we want to use LLM to reason about this and try to give us a solution here. Now, because LLM doesn't have that data inside, I need to enrich it. So I need to have a context database, that memory database, where I'm going to provide a system prompt. System prompt will give instructions to LLM how it needs to behave. And then also I need to provide this conversational history to be able to make it stateful, so it remembers my interaction. Also, maybe I'll provide my incident history, to give you more information when LLM is reasoning about this. And then LLM here, because we're going to use a chain of thought, is going to instruct the agentic system to call certain tools to get some additional information or do some updates. So for example, in our case the tool will be, okay, get me some information from a customer so I can update the billing address. Then this tool is going to respond with observation that goes kind of back to LLM, and different tools can be used. I will show you an example of that. And then when this is kind of resolved, we can also use kind of human in the loop, especially when we do maybe some updates or writes, that could change and have some risk impacts. Maybe we would like to have a human in the loop to verify that step. Maybe that's something we're going to start in the end, and then go more and less using the humans in that flow. And in the end, I want to report back with the system. Now, because, as I said, you need to kind of complement this, because LLM doesn't do that. So you need to have, you need to have an agentic system to perform these actions for the LLM itself. Now, it's just an example of system prompt. You don't need to read this, but the idea is to kind of explain here how he needs to act, kind of in a loop of thought. You define it a specification, kind of a contract of the tools he can use. You give him an examples how he needs to reason about it, Now, there is an emerging, as I said already, emerging protocol to be able to kind of standardize this with MCP. But this is we're going to feed the system as a system prompt. And this is part of system engineering. And again, we are not experts in this, but we can provide a way how you can feed this and kind of in a loop to be able to evolve this in the future. Now, the implementation here would be we have a system, we have an LLM, we know we can have a context database to store our system prompts and store our history for implementing a stateful session. Now we'll need to have an agent, something that is an instance of that agent that is responsible per that specific incident. So I have millions of incidents, I need to have millions of these agents representing this. Or I need to define a way how I'm going to scale that out. Now this agent is responsible then to get the system prompt, get the conversation history, then send us all to LLM. LLM needs to reason about it, and send now chain of thoughts and okay, I need the tool 1 to execute. So in our case, an instance will be, we are missing the billing address. I'm taking the context, I'm sending it to LLM, and I say, okay, now I see that there is a missing address there. Can you now call the tool, let's say, can you call the customer service, get me the address of that customer with that ID? Then you will store the conversation, of course, inside, and then these agents would give that responsibility to another agent that's going to implement the integration with your system, whatever that protocol is required, get that result back, and then feed it back to the LLM. Now, LLM again does the same thing, gives instruction to need to call another tool that you want to do. So our case would be, okay, can you update now that payment with that address that I pulled out? And then you will do that again. Maybe you will need to have a human in the loop. So some of these agents will require you to have that event-driven communication towards the human to approve it. That will be, for example, if, and we'll see in my demo, is that I'm going to also allow it to update that payment. So maybe I want to have a confirmation from a user that he wants to confirm that really that makes sense. And then, of course, when everything is finished, LLM will say, okay, I'm done with this, so that makes sense. I will send the report back to the system. Now, in this way, you can kind of automate that flow. Now, if we map this to kind of using the components in Akka, we can first use here, and this will be kind of context data, will be split into two things. One is first that store inside of the workflow is going to store all the conversation steps inside. Then we have an entities kind of memory database to store our prompts in, and we have an endpoint that's going to allow us to kind of manage and evolve these during time. So first, from our system, if that's, for example, some kind of a streaming, you can have a consumer that's going to stream in events in. It's going to send that incident to our workflow. Now, workflow here, the instance of that workflow is per one specific incident. It handles all the steps that we need to do in orchestrating. It's not orchestrating it, it's more orchestrating the execution that LLM in the end is defining. Now, first, it's going to send that information to LLM. Now, LLM is going to say, okay, I want to execute tool number 1. Now, this knows that based on that response, I need to push that to a tool number 1 workflow that's going to be responsible for handling then these steps of integration with that specific API I have here, or system. Yeah? And then the same things applies with other tools. Now, when this is all finished, I can have, for example, an instant report producer that's going to consume the events also from this workflow. And then if it's a finished one, it can also produce that and send it to the system. And again, I can also use a human in the loop in that sense. Now, let's show you this. So here I have so we implement a mocking system for an invoicing and for the payment system. So we're going to kind of simulate that we have raised an incident with a missing address. So this is going to now, as I said, send that incident to our workflow. Workflow is going to talk with LLM, and then is going to produce kind of an incident inside. Now we can see here. Refresh this. Okay, I can scroll it and put this. I can see it better. Okay, so this is where you have our incident came in with missing billing address. We have we have here, okay, there is a reconciliation failure due to the missing billing address. That's what LM sent us back. And says, okay, can you please call this tool, get customer details. Then our workflow does that information, sends that back. That's okay, this is a customer address. Now, since said, okay, now this is retrieved, now I would like to update the payment request that you have. Now I want to use a tool to update that payment. And here, I have here this was kind of updated payment, and then, okay, even here says, okay, the payment details have been successfully updated. Now, can you retry reconciliation again? And then you do this again, and then it says, in the end, LM says, okay, observation, okay, this was successfully done. Now, you allowed here that LM orchestrates fully getting all the required information plus updating the system. Now, of course, you would usually maybe have a human in a loop approving this update request, but I want to just show you how that in the future, hopefully, this can do fully automatically. You know? Now, this can be for any kind of types of use cases similar like that. Okay. Now, a little bit of a code. Now, this is the implementation of workflow. So what we have here is we have a definition of these steps. Now, I wanted you to focus on this part. So we define a step to, for example, send information to the LLM. Now here, in the call, we're going to use the specific AI SDKs. Whatever you choose, whatever makes sense. You will change them during time, how they're evolving, which one is better, and so on. Now, what this helps you to isolate how you call these things inside. So in case of failure, you can then very easily update the state that LLM failed, and then, for example, maybe you can include human in the loop in that case, or you can just send a report back. Or in case of success, you can say, okay, I have a successful request, and then I can transition back to, for example, let me choose the tool based on the response I got from LLM. And then I have each of the steps for each of these specific tools. And again, I'm isolating here, for example, here I'm using the component client. That's an Akka client to connect to any components running inside, wherever it is. And I can say, okay, for this tool ID, I would like to have that workflow created, and I want to start it. Now, this is going to send an asynchronous request to a workflow. Workflow is going to now autonomously work on collecting the information, updating whatever is needed. And then when it's finished, it's going to call this endpoint here with the observation and update that step and say, okay, I now want to send this to LLM. So it's very asynchronous and event-driven how this works, right? And here is a kind of definition of these steps. I can also include some of the resilience configuration, like, okay, in case of if this fails, I can fail over, for example, the human loop step. Or if I have an execution of these tools, I can try it multiple times, and if it doesn't succeed, I can also translate, for example, to send this to LLM, and LLM can reason. If I have observations, okay, something failed, maybe then LLM can instruct me to do some other tool that I can call. So you can also use an LLM kind of to do in a failure scenarios, but you can here you think about how you model these failures. In each of these steps that happens, is it connected to a specific tool or a specific system that you're connecting? You're modeling and you're isolating that inside of your code and then handling that. But what this framework does underneath, it helps you how you can scale these things and also does all this persistence for you. So you only model your business logic around that specific state. Now, I didn't go deep into the code, so if there's any interest, we have here a booth, number 9. Feel free to stop by and we can go in much more details. And then this is, for example, of a workflow to implement a tool. A very similar thing, you define kind of execution step where I can do different calls towards, for example, pushing that to an API, pushing to a message broker. And here I have even an asynchronous function where I say, okay, I want to execute this call, and then when I have an observation, I update, and I want to, after that, send that observation step back to my initial workflow that is handling the communication with LLM. So this is what I do here. So I have a component client, and I'm sending that information, kind of the tool observation reply, sending back to initial workflow. Now, these are kind of two ways how to implement these consumers and producers. So you can very easily, for example, connect to a message broker to consume these different incidents. You just have an external kind of contract that you use, and then you just kind of pass that to a workflow. So here it basically creates a new workflow for that specific instance ID, and then it starts here. And of course, if you want to kind of feed it back to the system, you would have a producer that kind of consumes from our workflow instance, and then maps that state change to a message that needs to be produced out. And now you can configure on a platform which kind of message broker you want to use. Okay, so let me show you another use case. Now this will be kind of more stereotype RAG use case. It's kind of chatbot assistant. So let's say you want to implement something like a ChatGPT, but you want to do it with your own content. You don't want this to be public, so it's not a public information, so it cannot be trained with a model because it is not accessible. So let's say you want to build something like this. Now, this is a more simple one because it doesn't require that level of automation, but still is an interesting use case. Now, a user wants to search for something from that documentation. Now, you need to provide, again, your resources inside, and you also need to provide a contact database to be able to give them a system prompt how it needs to react, and then also you need to feed it with the conversation history to remember it. Now, the system prompt will be kind of, okay, I want to provide you, in this demo, I want to provide you Akka SDK documentation. Now, it's public here, but let's say we are kind of simulating that process. And I'm instructing LM, you only need to use that specific information. If you cannot find an answer, just give me back, sorry, I don't know how to help you with that. Now, how do we implement that? Very simple. So first, what we need to do with the RAG, we need to enable how to do augmentation. So to augment our prompt, we need to do embeddings. So we need to have an agent that needs to load the resources from a source where I have internally, is that a Git, is that S3 or whatever I'm holding that resources in. I need to do embeddings that fit the LM that I'm going to use. And I need to do that as a standalone autonomous process, right? Maybe there is additional information, different resources coming in, so I need to also implement it as like a durable execution. Then I need to have an agent that's going to accept user prompt, needs to get system prompt, conversation history, send it, augment that using the semantic search on a vector database, and I need to send it to LLM, get back the response, again, store the conversation for the next, and then you return the response back. Now, this is kind of, let's say, if we simplify how the ChatGPT would work, right? Now, using Akka, we'll again use these components. So here, we would use a workflow to implement these steps needed to autonomously read resources, do embeddings, and store them inside. We would have, again, a context database consists of a system prompt entity, like in-memory database. For that, we would have an in-memory database instance for each session that we have. And then we have an HTTP streaming endpoint to be able to stream, for example, this request inside, and also responses back, because it's kind of a very conversational way to do. And then, and each of the prompt, we would get the prompt, get the conversation, and then return this back. Now let me show you. So we have this chatbot called Ask Akka. Now, I already prepared the prompt that I have there. Now I want to ask him, okay, what is the workflow? Okay. Now he's going to use internally the thing that I augmented, and then give me a result. Hopefully it will, or not. Okay, I did the first demo without any problem, so that's a success here. Okay. Okay, let's keep this one. But also, if you put, for example, inside, okay, what is a QCon? It only goes inside of the information that you shared, and because we instructed with the system prompt that we only want that information in, is going to say, okay, sorry, this is not information that I provide. So this is a way how you can provide, for example, if you have internally, you have some documentation that you want to share, you can then use this pattern to implement that in. Now the complexity will be more in how to integrate also with different resources. So I'm going to show you. It's a little bit of a code there. Okay. So again, we have here our flow. This is a kind of state that I want to manage different files I need to process. So I implement the step to list the files and kind of do the embeddings. Again, here I'm kind of wrapping, isolating all the calls, so I can, in case of failure, I can act and do different transitions depending on the failures. And also the embeddings, I would use different kind of, for example, vector database or different tools to do the embeddings inside. And then in case of any failure or whatever, I can then use this to transition to other steps. So in our cases, if in case of failure, just retry with the listing again. Yeah? And again, we can use some kind of retries or, for example, timeouts to repeat these things in. And then here is, for example, an example of this entity. Now we have conversation stored in. And this is kind of our domain. And then we just enable, this is kind of very declarative API that you can use where you instruct saying, for this conversation that comes in, I want to just store a new conversation with origin this content, and then return the list back. And this is the way I return only the list as a read mode. So I can use this using the component client in any moment to access our conversation for that specific session. And this is a streaming endpoint. Now, here we are using Akka also provides a reactive stream framework, so you can very easily implement different kind of streaming fashions to implement that. Now, for example, it's providing like server sent events to be able to kind of reply back in more persistent connection fashion. But here is, again, we are storing the conversation from the user, we are taking the system prompt, we are again wrapping here the AI SDKs, and then based on that, we're also storing then the conversation back, and then we are streaming the response to the user. Okay, and the third and the last one is live video. This is kind of American sign language recognition. So here we used a Gemini LLM to be able to kind of do recognition of the signs that we do. Now, it's a little bit clanky with the video streaming here, so I hope this will work. But the idea is that we want to stream a video directly. We want live, while we are streaming, we want to augment that with a system prompt, instructing that, okay, who is doing that? Alan is doing that. And also, I'm learning the ACL alphabet, and I want you to kind of, I'm guessing, so give me a confirmation, did I do it right? If not, give me information what I need to do to be able to show that sign correctly. Yeah? Now, still, we need to have, in this case, we're not storing conversation history, we're only storing kind of the system prompt for that. Now, again, a pattern, an agent, you're streaming the live video in, you're getting that system prompt, you augment that stream with that prompt, you're sending that to LLM, and then LLM is replying back. And again, using the components, using the gRPC stream, for example, here, so we use the gRPC to stream it in. You stream the request in, use the system prompt to augment with the system prompt. We store the conversation in, and then we stream that to LLM and stream the response back. Now, let me show you this. Okay. Okay, so here, now this is streaming in, so let me see. Okay, if I say, is this a C? Okay, that is correct. Unbelievable. Is this O? Oh, I'm absolutely right. Unbelievable. Okay, so here what it does, so it streams this video I have here using gRPC, augments that with the prompt I have, streams that to Gemini, and then streams the response, that text, back in streaming fashion. Now, the importance here is that we need to be able to back pressure, because we'll have these LLMs with streaming APIs, and because they are slow and we have a lot of things, we need to be able to back pressure these requests, cache the requests, and that's the thing that we need to think about when we build also a more industrial system. And a little bit of a code. I mean, here you will see we have a gRPC endpoint that we're implementing. Now, again, as I said, we are using this reactive streams framework from Akka, so we can very easily kind of declare the client. So even here, we did implement ourselves the Gemini streaming client using the Akka streams. And then it's just, okay, query basically the system prompt. Then you concat that to initial stream that you're getting from the request inside. You connect to the client, and then you kind of stream, you're storing here the conversation, and you're streaming that back. So this is the only code that you need to do to be able to implement a full bidirectional streaming with augmentation towards, for example, the Gemini client. Yeah? And that's also done in a very scalable way. Okay, so I'm done. Now, just to summarize, because our perspective here is what you need to have. I mean, it's focused on having a production-grade platform for enabling you to implement these AI patterns. Of course, you will use different tools specific to the AI, and also you need to be able to control them. You need to control, you need to embrace the failure, you need to model things around the failure, but you don't need to think about how to scale it, and you need to think about what is the level of resilience. That needs to be solved by the platform. That's what, in the end, Akka provides. So we kind of have a kind of call to action here where we kind of do proof of concept in 48 hours. So if there is any interest kind of to prove, if you have a use case that's interesting and kind of fits something of this, and you see, okay, maybe that's just a talk they do, so we want to kind of walk. So if you're free, you can kind of contact us, and maybe we can prove you that really works as we are talking about that. So thank you very much. Questions here? I don't think it's not that clear. But feel free, if you are shy, feel free to stop by our booth 9, and we can have an open discussion. Or yes?
Could you, I don't know if it's possible, but could you give an example of like the back pressure thing you're talking about all the time? Because I'm really curious about that.
Yes, I mean, there are different patterns how you can do it. No, or you can using the streaming library.
Sorry. Should I repeat the question in the mic?
The recording won't pick it up.
Okay, sorry. Repeat this.
I'll repeat the question.
Yes.
So can you give an example of like the back pressure thing? Because these LLMs are typically slow, and suppose there are like 5 or 6 or even 10 of your video streaming clients, and what with the back pressure, what does it look like inside your Akka, the configuration, etc.?
I mean, here the back pressure is built, so there are different ways how to do it. So in this specific case, the back pressure is built in this streaming library that we are using. So basically here, in this using our library is doing the back pressure. Now, if you want to, there are different ways also how you can do, for example, workflows or multiple instances of workflows that represent different clients, stateful clients toward LLMs. And they would kind of queue different requests, allow you to kind of control how many instances are running. Because when you have a scale, the thing is how you can control number of instances accessing, for example, and controlling, let's say, counting the tokens that you used. So, or you kind of scale it by creating a stateful clients that are going to represent these requests, and they're going to queue this request toward the LLM. So that's one other option. Workflow can handle that in a stateful fashion and with resilience and count it in. Or in this case, you can stream it directly. Now, you can also control these streams with a workflow. So you can feed that in the workflows inside, and they can stream things in. Now, there are different combinations, but if you have a use case, so stop by, and I can show you some details about that. Yes?
Yes. I only saw that you show code based on Java. Do you guys have a Scala API?
Yeah, that's a good question. I mean, Akka was built on top of Scala, but our focus for a longer time now is more around Java community. I mean, system engineering, of course, is focused on different programming languages, but at least the JVM world is somewhere where we can give the guarantees that when you implement something like this can scale and this can be resilient. Now, the Scala, for now, we don't offer. This is something that we have in roadmap and will depend on demand. But for now, we didn't have explicit requests for Scala. And I mean, the reasoning is because you can see, I mean, it's a really high-level abstraction that you use. I mean, using the programming language or advantage of programming language don't matter that much because a lot of things are handled underneath by that abstraction. Yes?
Hi. I'm just looking over the code that you showed where you add steps in the workflow to use different tools. Okay. Is the agent able to determine the order in which those steps should occur, or whether some can occur in parallel, or whether the result of one tool is needed for the next?
Okay, so I'll show you here. So maybe that was not clear. So here, for example, in this case, so we are calling the LLM. So LLM is going to return us back the tool that we need to execute, right? Now, we're going to take a function that's going to, based on response, indicate which tool I need to call, right? So it could be, for example, get customer data, update request. And then based on this, we can return back or this, or whoever step we have defined. So basically, the decision-making here, or decide that you have, is defined based on the response coming from LLM. So LLM is basically orchestrating which tool you need to call. You're just proxying things. You're kind of giving that responsibility to others to do a durable execution. But compared to a standard workflow where you have that static, this would be a way how you do that dynamic execution. So you just define the steps that you have, and then you allow LLM from a response of a chain of thought to give you to which step you need to transit to. Okay. Any other questions? Okay, I hope this was helpful. And again, I invite you to our booth if you have any additional questions. You're shy. Or here, of course. Thank you.